this last speaker of the day, we've had quite a range of speakers, starting with Ms. Wilson to civic leaders, mayors, and we're going to end the day with one of the world's thought leaders, and not only thought leaders, one of the most productive and impactful urban ecologists, Nancy Grimm. She is the Regents Professor at Arizona State University. She has a very long list of accomplishments. I'm just going to highlight two that are really relevant to this group, everyone in this room. She was the founding director of the Central Arizona Phoenix Long-Term Ecological Research Program. And for those of you who are not familiar with that, this is a more than 20-year investment by the U.S. National Science Foundation to study urban systems as coupled ecological human systems. She founded this program. She led it for many, many years. And the science that's come out of that program has had an impact all around the world, not just in Phoenix, Arizona. The other thing that Professor Grimm has done is that she has co-directed the Urban Resilience to Extremes Sustainability Research Network, which is a network of networks, and again has had impacts well beyond the state of Arizona. So without further ado, please join me in welcoming Professor Grimm.
Yeah, okay, that sounds great. Hi, everyone. Thank you very much for that very kind introduction, Karen. I really appreciate it. And I think I can move on to the slides. Is that right? Okay, so I'm going to confess, well, maybe you just heard, I'm not a forester. And you can tell me during the reception if you think that's a forest. That's Phoenix, Arizona. But I am an ecosystem ecologist, and I love streams and cities. Those are the two things I study. I started off as a stream biogeochemist, and have been at Arizona State University for 45 years, so long time. The logos in the bottom are just some of the projects that couple that Karen mentioned and that I'll be referring to during this talk. But I want to talk about how we actually think about the future and how we think about the future with communities, with people that are making decisions, not just in academia, and also nature-based solutions for this period of time that we're living in, which is this era of rapid change that some call the Anthropocene. So I don't know if you all have seen this. This is sometimes referred to as the Great Acceleration, but the pictures on the left are things that people are doing, what's happening in the human sphere, and on the right, the resulting trends in Earth system properties. So things like the increase in carbon dioxide, increases in temperature, tropical forest loss, various things like that that you can see. And what you can see about this is clearly, first, this is really rapid change. There's been, we're in this era where things are accelerating in terms of how much they're changing, not just continually changing, but accelerating change. And so the impacts of that change become compounded. They're not just, one sector that gets affected, and we really have to think about how that goes across a wide variety of things. This has also resulted in our Earth systems, our urban systems becoming ever more complex. Not just complicated, but complex. Lots of feedbacks, lots of nonlinear responses and things like that. Unfortunately, this era that we're in is associated with a rise in inequity, and so we have to be aware of that as well. And then finally, increased uncertainty. We no longer can use our understanding of what has happened in the past to predict what will happen in the future. And another thing that I could say about that is the solutions of yesterday are the problems of today. So we really need to be thinking about thinking toward the future. So everybody talks about climate change and 2 degrees C or staying below 1.5 degrees C. And this is really, I just love this figure because you can actually see an animation of this. But if you see this goes from 1880 to 2022, and you can see that the darker red colors are all on the top, right? So the temperature has gone up. There's no question about that. The global temperature has increased. But there's maybe too much attention paid to temperature, because in fact, what also is happening, and this year is a really great example of that, isn't it, is that natural disasters are on the rise. And in this figure, which goes from about 1980 to 2017, you can see that a large number of natural disasters have increased. All of these colored portions of the bar, except for the red, are climate-associated changes. So things like storms, floods, mass flows, fire, drought, etc. So all of the people that are living on Earth are experiencing climate change, not through this increase in global temperature, but through these extreme events. And unfortunately, the poorest communities are more affected by these extreme events than the more wealthy and more prepared communities. And so in the graphic that you see there, it shows the projected damage from climate change, economic damage, and on the x-axis is a ranking of US counties in order of per capita income. So it's the poorest counties that are expected to see the greatest losses, economic losses associated with climate change. So these extreme events are increasing in frequency, in magnitude, in impact, and cities in particular are particularly vulnerable to extreme events because they're located often along rivers that flood or along coastlines that are experiencing sea level rise, in drylands, they're experiencing drought and fire. But that risk not only is unevenly distributed between cities, but also within cities. So we see that cities are heterogeneous in terms of the distribution of these impacts of climate extremes. And so we're interested in understanding how cities and the communities within them can become more resilient in the face of these kinds of increases in extreme events. And I want to say right off the bat that the projects that I've worked on have focused mostly on climate adaptation rather than climate mitigation. But I think that you could take some of the lessons that I'm going to say away thinking about mitigation as well. So we formed in 2015 this network called Urban Resilience to Extremes Sustainability Research Network. The focus was on extreme events such as coastal flooding, extreme heat, drought, and urban flooding. And we selected 9 cities. The reason we selected these cities is because we knew people there. We knew they had connections with folks in the city that were decision makers. So we had teams that consisted of researchers as well as practitioners in each one of those. It was a really big project. We had a lot of people, a lot of institutions involved. A fair amount of funding, and it ended last year, but we're still analyzing data, as you'll see. But the 2 things I want to focus on, which I think are outcomes of this project that I particularly am proud of, is first the development of a conceptual framework around social, ecological, technological systems, which we think applies well to both cities and the things within them. And then secondly, the fact that in this project we actually co-created with city teams 60 future scenarios across these 9 cities. So these are scenarios that are looking at 2080. What would the cities look like? And I'll explain later what I mean by scenarios, but these are positive visions of the future. Okay, so starting with the SETS framework, we've continued to work on this framework. But basically, it's something that's needed because given that we're in this era of rapid change, we really need to think about how we design or manage our cities and the infrastructure within them, and I include in that infrastructure that is ecological, so nature, to embrace a more realistic framework about what the world is all about. So what has really driven the way that we've built cities, built infrastructure, and so forth is this perspective about controlling nature, right? So, and that rests on the assumption that the world is stable, that systems are complicated but not complex, that events are predictable, and so forth. And so what we're interested in saying is, look, if we think about social, ecological, technological perspectives, the entanglement of those three domains. The world is, in fact, rapidly changing. Systems are complex. Events are uncertain. Humans and nature are inextricably linked. They are not separate. We need to place a value on pluralism and diversity of solutions, not just this sort of one way, but most efficient way of building cities or infrastructure, and that these systems are integrated. So here's a sort of representation of the Venn diagram here of the social, ecological, technological system. Again, these urban resilience problems are problems of complexity, and so we need this convergent framework that brings all of these perspectives together. Cities have social components, ecological components, and technological components that interact. And we believe that urban resilience to extreme events emerges from the interactions and feedbacks among those domains. So you can't just go out and say, okay, we're going to fix the seawall and not think about how is it going to be managed, what kinds of ecological effects there might be, what kinds of people are most exposed, possibly down the coast to greater storm surge because of the seawall that you put in and things like that. So building resilience means that we are enhancing the capacities of cities to adjust, adapt, and transform toward the desired futures that we have. Now, this idea of sets has been around for a fairly long time. Some of the literature that we've actually produced and that others have produced is listed at the bottom if you're interested in looking into that in greater detail. Okay, then I want to just move on to talking about nature-based solutions and future visions. So one question and in our projects, we have been very interested in the incorporation of nature into the kinds of solutions that we can think about for these extreme events, for coping with extreme events. So can we integrate nature to build resilience? Will that help to build resilience to floods, extreme heat, and other extreme events? And then do people actually incorporate nature in their thinking about future visions when you sit them down and say, what do you want your city to look like in 2080? Do they think about nature being part of that? So I'm going to give you a little background here first on the city of Phoenix. Thanks, Ariane, for having introduced that to begin with. First, I'm going to go back to the urban forest, right? So is this a forest? I don't know. Tell me during the reception what you think. But what I can tell you is that the studies we've done have suggested that this 12% canopy, more or less, is really about the same spacing and abundance of plants as you would have in the surrounding desert. But the plants in the desert are shrubs. It's a scrubland. And so we're not embedded in a forest where we've reduced the amount of vegetation. And in fact, we've possibly somewhat increased biomass in the city. So Phoenix is a rapidly growing area. Boy, that's interesting. What is that? I think it says people. Yes, so it's a very rapidly growing metropolitan area that consists of some 28 municipalities. In 1950, there were 300,000 people approximately. In 2020, closing in on 5 million people. And this is a hot, dry area, desert area. And when Phoenix was first colonized by European colonizers in the late 1800s, they saw this as a potential for creating an oasis with agriculture and so forth. And so they planted cotton, they planted fields, they harnessed water, and they had to harness water to do that because you can't grow anything without water in this desert. Annual precipitation is about 200 millimeters or 7 inches per year. And some of that water came from distant places. The picture here is of the Colorado River, Central Arizona Project Canal. There were lots of modifications of the rivers that feed into the city and lots of modifications of the land surface associated with urbanization. And that water has enabled the kind of lifestyle that exists in Phoenix, although there is some transition, lifestyle that includes things like watered lawns, golf courses, swimming pools, excessive use of water in this way. And so water brought into the city that used to flow in the river no longer flows in the river. It sort of goes out into the city and into the fields and into people's yards. And stormwater is also managed in the system. And I want to talk a little bit about stormwater management and some of the changes that have happened there. This is my favorite example of a nature-based solution. This is Indian Bend Wash. That is an ephemeral wash that flows north-south through the city of Scottsdale, and it pretty much bisects this north-south long city of Scottsdale. In 1935, it was mostly farmland with this ephemeral wash flowing through it. That means it only flows in response to rainstorms. By 2000, this is what it looked like. So lots of urbanization and a green belt that was established in the early 1970s by the Army Corps of Engineers, who, in response to flooding in 1967, proposed something that looks more like this. And the citizens of Scottsdale said, we don't want that. And so they went back to the drawing board and they created this first flood management system, not flood control. So again, we get back to that, not doing control, but doing management. Where floods are managed, natural flood regimes are allowed to occur, but the consequences of flooding are much reduced. Basically, there's some debris that has to be picked up after a flood, but there's not a lot of damage to people or property. And there are co-benefits because there's parks along this wash and lakes and recreational opportunities and so forth. So this is what it looks like from the air. That's the city of Scottsdale looking north and the green belt there. And this is what it looks like when it's flooding. And this is a system that we call a safe-to-fail system. What does that mean? Safe-to-fail is basically if we acknowledge that risk is the product of the probability of something happening and the consequences of that something happening. What we're doing here is we're just playing with that distribution between probability and consequence. So the fail-safe method says, look, we know from past data that 1 in 100 years you're likely to get a flood that will exceed the capacity of this system. So we're going to build it up so that it's 1 in 100 years. So it's very unlikely to happen. If it does happen, it's going to be pretty consequential. Whereas the fail-safe method says, yeah, it's going to flood. That's what it does around here. And when it floods, the consequences will be minor. So this is a really good example of how you move from that control paradigm to one of an entangled sets paradigm. Okay, second example is going to be talking about resilience to extreme heat. And this is focused on South Central Phoenix. South Phoenix is one of the areas in Phoenix that is a historically underserved area of Phoenix. It was redlined in the 1930s. That's what that says, where you can't read it. In the early 1900s, there was flooding in the river, and all of the white population moved north. But then there was redlining that prevented people of color from moving north. And so this area was, at the time, had lots of these open canals and nice tree cover. And this is a wonderful picture of a community having a Sunday picnic in one of these. It looks like a pretty nice place to be, right? But in the 1950s, the canals were buried. The trees were all removed. 1950s and 60s, they were removing trees all over Arizona because they were stealing our water. That was the idea. Trees are stealing our water, so we're getting rid of them. This left this part of Phoenix extremely barren, dry, and hot. So this is a map of some of the Phoenix area with showing the heat vulnerability. The red is the highest vulnerability heat, and that area that I've enclosed there is in the South Phoenix area. And these are data that were gathered by Sharon Harlan and others. They had a long-term project on both climate change and local climate impacts on heat and on health. They also showed that during a specific heat event, which is on the chart on the bottom, this is a 4-day heat wave, that it was the neighborhoods that had the lowest income, significantly lower income, significantly higher percent minority that experienced the highest exposure to heat during this heat wave. So very clearly demonstrating this distribution of disamenities in the Phoenix area that is disproportionately affecting people of color and people in lower income brackets. Okay, thank you. So what we actually did, that's not true, because I started 5 minutes late. What we actually did was to develop with Maggie Messerschmidt, who was with the Nature Conservancy, a project working with communities to sort of think about how they could actually, what they would envision as ways to change their neighborhoods to make them more, to make them cooler. And this is just showing some projections, I'm sorry, for the future of Phoenix. And what you can see is this is the number of days in which daily temperature is above 110. As Ariane pointed out, this year we are we're up to what it would be in 2050 this year, so 55 days. So this is a map of land surface temperature. The big red spot in the middle is the airport, but the black outlines the neighborhoods we worked with. So we worked with these neighborhoods, picking them on the basis of their vulnerability, their exposure to heat, and their adaptive capacity. And you can see one of the neighborhoods contrasted here. It's in the hottest 4% of tracts, the lowest 5% of vegetation cover, and a much higher death rate associated with heat than the rest of the valley. So we did some community workshops where we sat down with communities, discovered the concerns that they had, and what were the potential actions they thought about. In a second workshop, we invited designers and decision makers to hear what they had thought about, and then in the third workshop, made decisions about what the priorities were. So this is a sort of map of the stakeholders involved, the core team that I showed you on the first slide. Community-based organizations, very, very important in connecting us to residents in these communities, and then to municipal decision makers. We also worked with the Center for Whole Communities to develop an assessment of how this process was working in terms of justice and fairness, community engagement, economic vitality, and community resilience. And what they came up with were strategies that varied depending on the neighborhood, but also there were some common strategies, and you'll all be happy to see that shade and trees are right there in the middle. Shade, trees, water, and bus stops. We heard about bus stops from Ariane earlier. And each community created their own plan, and they chose a spokesperson who went to the city government and talked about what they had found. And these are the plans. They're available online, and they're owned by the communities. Okay, now I wanted to look to the farther future scenarios, and here I'm going to just tell you what I mean by scenarios. I do not mean we're predicting what the future is going to be like, but rather thinking about storylines or narratives that can describe a positive future. And as I said, we have 60 scenarios across the 9 cities. What we've been doing is to analyze those in terms of their transformative potential. So we identified 240 goals across those 60 scenarios, and about 3/4 of those we deemed to be transformative in one of 6 different areas. Those areas are nature-human relations, infrastructure futures, climate resilience, social justice, governance, and economic reform. So it seemed like there were some interactions between those archetypes of transformation, if you will. But we also found, and this is work in progress, so it's not a final, it's just a hot off the presses sort of thing, that there were recurrent strategies, and some of these might be surprising to you. So car-free cities, Car-free cities was a common strategy across these. Energy infrastructure, connected green infrastructure. So not just trees, but connected trees. Procedural and distributional equity, a fundamental right to housing, healthcare, and water. Community hubs, web-based, water-based transportation. That one was really interesting. There were some that were like, we can go on the canals and have canal taxis. And then coastal retreat, and obviously that's just for the cities that are along coastlines. So that's for the big set of scenarios. Now I have a couple of more slides about the Phoenix scenarios, and we did these at 2 scales. These are the people that were involved as leaders, a core team for these scenarios. The large regional scale scenarios for Phoenix region were done over a series of workshops with about 80 academic and practitioner participants, about 50 in the local ones. And these are the scales. So again, this is the South Mountain Village or South Phoenix that I mentioned before. This is Phoenix within the Central Arizona Phoenix LTER. This is Maricopa County, which is about twice the size of Connecticut, just to give you a little bit of framework for size, right? So those are the 2 scales. And what we do in each of these is very similar. We did this in all the cities that we did scenarios. We start off by sort of explaining what the current and future challenges are, and we talk about that, develop that. The cities all developed a set of themes that they want to use in thinking about the future. And in each theme, they sit down and develop goals. Then they assign strategies to those goals, how we're going to meet those goals. Details, like where in time and in space would those strategies be implemented. And then they end the day or the week or whatever with a series of stories that they tell about a person, a day in the life of that person. And in 2080, what would it look like? How would they interact with their environment? And so I'm not going to go through these, but this is just to show you the different visions that came out of the regional. There's 3 that are sort of more dealing with extreme events and 3 that are more transformative, if you will. And then the 5 that came out of the local. Interestingly, this was a theme that was suggested by the local community, that they have an equity district theme, which I thought was quite interesting. And there's some that are similar. So there's the desert wetland is against flooding, and that is paralleled with the mountain to river, which also has an idea of adaptation to flooding. And so, for example, in that mountain to river scenario at the local scale, these are the goals that they came up with. They're big goals. So they have a community-held vision, watershed management that is integrative, and connectivity between the mountain and the river that aligns with human access. And these are some of the really nice drawings that were done during this workshop and after the workshop. So these workshops on both scales produce these tangible futures. They, in the regional scale, the sort of idea of eco-design and greening were prevalent. At the local scale, it was more about honoring place and concern for equity. These workshop data then are usable by researchers, design students, modelers, and I just want to show you a couple of slides to illustrate how we can use the data in a modeling framework. So this is going to compare just 2 of the regional scenarios, one that is focused on adaptive drought, that is long-term water security with conservation of water and water banking, and then a transformative scenario that's balancing targets for flood, drought, and heat. So taking care of keeping people cool, but also worrying about future water. And we can take those workshop data about where these different strategies should be implemented and create these spatially explicit maps. This is for the Phoenix regional area. And you can see that this true cost of water, the drought scenario, has the city becoming much more dense, but much less green, compared to the transformative scenario that has a lot of green in it. Now, we can take those data, since they're spatially explicit, and feed those into models. So our colleague Matt Georgescu modeled with the Weather Research and Forecasting Model, WRF, the heat load that would result. And this is what you can see for the heat outcomes. This is a much hotter environment than this one, and this is just temperature above sun base, surface temperature above sun base. So you can see that this is useful for actually being able to think about what the situation would look like and evaluate trade-offs. And there are trade-offs in this, because on the one hand, you're banking water. On the other hand, you're not banking water. And so if we look at water banking, what we see is that that true cost of water has a much greater water security for the future than does the transformative Emerald City. Okay, this one last thing, we can compare these scenarios at these two scales. We've developed a qualitative assessment called RESCUE, Resilience, Equity, and Sustainability Quality of Assessment. It's just published this year in Sustainability Science. And again, these are the sort of main things that came out from the comparison of these two. But what you can see is that in terms of equity, the local scale, the green, had much higher representation of equity in their scenarios than did the regional scale. And you can see this in some of the drawings, that, this sort of idea of place and pride in the place and that sort of thing. So that's the story from the scenarios, and how I think that what you see is that there's quite a lot of incorporation of the ideas of greening cities and so forth in people's ideas about what they would like the city to look like in the future. And if I can just take one more minute of your time, I just want to put in a little plug for this network that is about in its third year now. It's a network of networks called Nature-Based Solutions for Urban Resilience in the Anthropocene. This is being led by myself, Timon McPherson, and Elizabeth Cook. It's a network of networks, as I said, all around the world. These are some of the networks. We're up to 45 or so now. And at the COP15 last year, we announced our global roadmap for nature-based solutions, where we have 7 regions around the world that are collecting case studies of successful implementation of nature-based solutions in cities, which will be feeding into a number of ongoing roadmaps and plans that are going on around the world. So if you're interested in learning more about that, that's our website. We'd love to have people join, and I thank you very much for your attention. Do I get to answer any questions, or do we go? Oh, I think we go. We go out there, because if you have questions, then ask me with something in your hand.